Hi, welcome to #Math. If you watched the previous 4 videos, you are ready to graph polynomial functions. Let's do it. Our goal is to graph this polynomial. Let's start by finding the y-intercept. For that, we set x equals to 0. So we're just finding p of 0. Plug in 0 everywhere you see x, and you get the y-intercept. So we get 1 over 36 times 0 minus 2 squared times 0 plus 3 cubed. And that is 1 over 36 times 4 times 3 cubed, which is 27. This 4 cancels with a 4 here, leaving us 1 over 9, the 27, a 9 and the 27 cancels with this 9, and we're left with a 3. So p of 0 is 3. That means my y-intercept is 0 for x, 3 for y. We start recording our findings in the coordinate plane. Here it is, the y-intercept. Let's find now the end behavior. The end behavior is the leading term of the polynomial, and we get it by multiplying the highest powers of each piece, like this. We do 1 over 36. The highest power of this factor is x squared. The highest power of this factor is x cubed. So the leading term is 1 over 36 times x to the 5th power. We have an odd exponent and a positive number. That means that our graph ends like a quintic. As x approaches infinity, it goes up. As x approaches negative infinity, it goes down. We can describe the end behavior by saying, as x approaches infinity, p of x approaches positive infinity, and as x approaches negative infinity, p of x approaches negative infinity. Let's find the x-intercepts. For that, we set y equal to 0. So we have 1 over 36 times x minus 2 squared times x plus 3 cubed equals 0. This is true if each factor is 0. That means if x minus 2 is 0 or x plus 3 is 0. And x minus 2 is 0 for x equals to 2, and x plus 3 is 0 for x equals negative 3. So these are my x-intercepts. Negative 3 for x, 0 for y, and 2 for x, 0 for y. Let's plot them in our graph. Negative 3, 0, 2, 0. So we have two roots, negative 3, that correspond to this factor whose multiplicity is 3, which is odd. It means crosses the x-axis, and the root 2 corresponding to this factor whose multiplicity is 2, which is even, and that means it touches the x-axis. Let's analyze the behavior near 0 for each root. So let's start to see how the graph looks like near negative 3. We do this by plugging negative 3 everywhere except to its corresponding factor. So we plug it here and not here, and we get 1 over 36 times negative 3 minus 2 squared times x plus 3 cubed. So we do not plug the negative 3 into x plus 3. We are really concerned here is about the sign coming up from the numbers, not exactly the number. For this, we can say that this is going to be a number which is positive because this has been squared times x plus 3 cubed. What this means is that our polynomial crosses the x-axis like a positive cubic, or a cubic that has not been reflected. Let's graph that. At negative 3, it crosses like a cubic, like this. Now let's look at the behavior near 2. We plug in the 2 here, but not in the factor corresponding to 2. So not here. And we get 1 over 36 times x minus 2 squared times 2 plus 3 cubed. What we get here is a positive number times x minus 2 squared. That means that the graph is going to touch the x-axis like a parabola opening up, because this is positive, like this. And we're ready to graph. Just follow the instructions. So we come from negative infinity, cross the x-axis like a cubic, continue to our x-intercept, go down to touch the x-axis like a parabola, and go all the way up to positive infinity. And that's our graph. Okay, let's work out our second example. First, we find the y-intercept. For that, we compute q of 0, and that's clear because this is 0 over 21. Whatever comes here is going to be multiplied by 0, so that's 0. Our y-intercept is 0, 0. Now the end behavior. It results from the highest powers of x I can find in each piece. The first piece is just x over 21. From the second piece, we get 2x cubed. And from the third piece, we get 3x squared. Those are the highest powers. And this is x over 21 times 8x cubed times 9x squared. 1, 3 from this 9 cancels out with 1, 3, leaving us 7. And we get 24 over 7x to the 6th power. So my end behavior is like a parabola opening up because the number is even. On the graph, it's going to look like this. Both ends going up. We describe it as x approaches infinity, q of x approaches infinity, and as x approaches negative infinity, q of x approaches positive infinity. To find the x-intercepts, we set y equal to 0. So we have x over 21 times 2x minus 3 cubed times 3x minus 7 squared equals to 0. That is 0 if x over 21 equals 0, or 2x minus 3 equals 0, or 3x minus 7 equals 0. And that is x equals 0, or 2x equals 3, just adding 3 on both sides, or 3x equals 7, adding 7 on both sides. Then this is x equals 0, or x equals 3 halves divided by 2 on both sides, or x equals 7/3 divided by 3 on both sides. And we're ready. We have 3 x-intercepts, which are 0, 0, 3 halves, 0, and 7/3, 0. The roots are then 0, 3 halves, and 7/3. 0 has multiplicity 1, so it crosses at 0. 3 halves has multiplicity 3, so it crosses at 3 halves. 7/3 has multiplicity 2, so it touches at 7/3. How does our graph look like near 0? So we plug in 0 everywhere except at x. And what we get is x over 21 times 0 minus 3 cubed times negative 7 squared. We're concerned only about the sign. The sign in the first factor is negative, and the second factor is positive being squared. So we get a negative number times x, which means at 0, my graph is crossing like a line going down. Now let's look at the behavior near 3 halves. So we plug in 3 halves everywhere except here, and we get 3 halves over 21 times 2x minus 3 cubed times 3 halves minus 7 squared. This factor is positive being squared, and we get here is a positive number times 2x minus 3 cubed, which means that the graph is crossing at 3 halves like a positive cubic. Let's graph that. At 3 halves right here, my graph is crossing like a positive cubic. Now let's look at the behavior near 7/3. Plug in 7/3 everywhere except here. So we get 7/3 over 21 times 2 times 7/3 minus 3 cubed times 3x minus 7 squared. Again, we're concerned only about the sign. 2 times 7/3 is 14/3, which is bigger than 3. So this here is positive, and this factor is also positive. So we get a positive number times 3x minus 7 squared, which means that the graph is touching the x-axis at 7/3 like a parabola opening up like this. And we're ready to graph. Let's go. We come from positive infinity, crossing 0 like a line going down, go down and then up, cross like a cubic, go up, then go down and touch like a parabola and then go up. And that's our graph. Let's just erase this little piece there. That's our graph. Thank you.